All right, hi guys. Today we're doing 10.5 day 1. We're looking at a new operation with vectors today. Our new operation is called the dot product. So we've done our very basic adding, subtracting vectors, and then multiplying by a scalar. Today we're looking at something called the dot product. So here it says multiplying vectors, like actual vectors together, is not like multiplying scalars or regular numbers. It's not like multiplying 5 times 2. So one of the ways that we can sort of multiply vectors is by finding what's called the dot product of those two vectors. So it works pretty simple. In our box here, we'll fill in how to do it. It says if vector v, all my little arrows disappeared, but they're vectors. If vector v is represented by a and b, and vector w is c and d, the dot product, so literally represented by a dot between them, that's why it's called the dot product, can be found by doing a times c, so I'm just going to write them next to each other, plus b times d. Now notice that this is not a vector. This answer is just a regular number. Okay, it's not a vector when you find the actual dot product. So a couple things we can add here, and I'm going to type in for the fill in the blank. So it says the dot product is a scalar. So that's what I meant before when I said it's a regular number. There's no vector brackets. And it is commutative. So that means it doesn't matter if we do v dot w or w dot v. The order can go both ways. You'll get the same answer. Another fact here, if the dot product equals 0, then we can say the vectors are perpendicular. And hopefully we remember that perpendicular means that the angle between the two vectors would be 90 degrees. Okay. This is our big fact for today, finding whether vectors are perpendicular by calculating the dot product. Okay, so let's just start by calculating the dot product of a couple vectors. So I don't know why all my little arrows are all messed up, but anyway, if we're given a couple vectors u and v, here are the vector values, let's find the dot product. So when we read that out loud, we say u dot v, not times, because it's not really multiplication in the same sense we're used to, so we say u dot v. And we'll follow the formula from above. So in words, we're basically multiplying the corresponding pieces and then adding those together. So we'll do -4 from the first vector, that's a 4, times 3 from the second vector, plus 2 times 6. So multiply the corresponding pieces and add those up. -4 times 3 is -12. 2 times 6 is +12. So this time we actually got 0 for our dot product. So what that means is vector u and vector v are perpendicular. Now our symbol for that, remember, is like the upside down T. That means perpendicular because their dot product is 0. And if we just quickly sketch them over here, we can kind of see what that looks like. So -4 up 2. Oh, this is going to be terrible. So here's the first vector u over 3 up 6. 6. Oh, I totally missed it. Here is vector b. Close enough. So you can see here the angle between them. It actually looks pretty perpendicular. It looks like it's about 90 degrees. And then mathematically we're showing that. Okay, so our first example here, it asks if any of the following vectors are perpendicular, meaning any combination of two vectors from this group of 3. So we have to have all 3 pairings. So our first pairing would be p dot q, and then we can also do p dot m, and our third pairing would be q dot m. And we're going to just find the dot product of each one and see if we get 0 or not. So p dot q, we're doing 7 comma 14, dot 3, comma 5. So we're going to multiply the pieces together, 7 times 3, and then add them, plus 14, whoops, times 5. So we get 21 plus 70, which equals 91. So we did not get 0 for the dot product. So to answer the question, we're going to say no, these ones are not perpendicular. Okay. So see if you can find the dot product of P dot M and Q dot M on your own, and then decide if they're perpendicular or not. All right, here are my final answers for the other two pairings. So P dot M, I said yes, those are perpendicular because their dot product equals 0. Q dot M, I got a dot product of 1, so no, they're not perpendicular. Okay. And then our next question, same question, are these vectors perpendicular? But this time we're looking at three-dimensional vectors. And just like with our other operations, a three-dimensional vector, the operation works the same way. So to find the dot product, we're going to multiply the corresponding pieces and then add those values up. Okay, so I just rewrote it with my operation in the middle. And then I'm going to do 7 times 3 plus negative 2 times 8 plus 4 times 1. I get 21 plus negative 16 plus 4, which equals positive 9. So again, I did not get 0 for the dot product, so I still answer the question, no, they're not perpendicular. And our very last problem together here. So this is kind of going backwards a little bit from the dot product. It says what value of B will make the vectors perpendicular. So here we have a missing piece of this three-dimensional vector. So if we want to figure out that value, we're going to just set the dot product equal to 0. Because we know that it should equal 0 for the vectors to be perpendicular. So we have negative 2, B, 8, dot 16, 4, 2 equals 0. Now you could do a lot of guess and check here, but we can do this pretty quickly algebraically. So let's just continue working through our dot product. Negative 2 times 16. Here we have plus B times 4. And then plus 8 times 2. So I'm just doing the dot product like normal, except this time I know what the answer should be. Negative 32 plus 4b plus 16 equals 0. 4b minus 16 equals 0, right? I'm just simplifying the algebra here. 4b equals 16, solving a linear equation. So dividing by 4 on each side gives me that b equals 4. Okay, so the last thing I want you to do is try these three problems on your own, and then you can check your answers. All right, here are my final answers for each pairing of these three vectors. So you can definitely pause the video to look a little bit more closely at my work. But quick summary, P dot Q, yes, that is perpendicular. P dot M is not, because I got a dot product of negative 32. Q dot M is not perpendicular because of my dot product of negative 38.